Hello, my name is Ben Ramirez, and we're going to be covering pages 695, 739 from CISSP All-in-One Exam Guide, 6th edition for Harris Chapter 6. And we're going to be covering remote connectivity, such as dial-up connections, ISDN, DSL, cable modems, VPN, and authentication protocols, as well as looking into wireless technologies such as wireless communications, WLAN components, wireless standards, war driving for WLANs, mobile wireless communication, and mobile phone security. Okay, so let's take a look at the benefits and uses for remote connectivity. It allows users to access network resources from anywhere in the world. This definitely reduces costs. You don't have to spend a whole lot of money on capital expenditures for large pieces of equipment to get this done. And it allows users to use different types of technologies like laptops, mobile phones, or any other device like tablets in order to get remote connectivity. There's different types of technologies to get this done. We have dial-up modems. Modems have been around for quite some time. A modem is basically nothing more than a modulator, demodulator device that modulates an outgoing digital signal into an analog that will be carried over with a carrier signal, and it'll demodulate the incoming analog signal to a digital transmission that can be processed from the device. These things are actually susceptible to war dialing. War dialing has been around for some time too, where attackers basically use a long list of numbers. They put it into some kind of database where they can call each number to see if it's connected to the network. We have security measures in place, so we can disable the modems that we don't need. We can configure the modems, or we can use two-factor authentication or on remote access in order to protect ourselves. We also have ISDN, which is Integrated Services Digital Network. This is a type of technology that provides data, voice, and other traffic into a digital transmission. And it's like a modem, but it has higher quality services. And these services these services include speed. Of course, it does have a much higher speed than the regular modem, and it also accomplishes the ability to create a quick connection. It only takes about maybe 4 seconds, maybe 5 seconds to get a connection to the network. In addition, ISDN does provide two services, primary rate interface, and rate interface. And we also just want to make sure that we understand that ISDN is not really used anymore, but if we don't really have anything else to use, we can use it as a backup. It's not really common for corporate, but it is used for backup services. Now, DSL is something we need to talk about. DSL is also a different type as well. It's a digital subscriber line, basically, and it's 6 to 30 times more bandwidth, provides more bandwidth than ISDN and analog. It gives you a 24-hour connection, so it's always on. You don't have to dial up anything. And it gives you symmetric and asymmetric services, which means that either your speed can be the same it can be the same going up or down, or asymmetric, meaning the down speed or the download speed is faster, but the upload speed is a little slower. And it's most common with home-based networks because they don't really need a very fast upload. Cable modems have been also around for a little while. With companies like Time Warner Cable, they provide television services, but now they're providing internet services as well. They provide high-speed access up to 50 megabits per second, also giving you 24/7 capabilities. They use coaxial and fiber cable lines. They don't use copper wire, but they use coaxial and fiber cable lines, so it's very different. And they're prone to network sniffing, so that's something you might want to also take care of in terms of trying to make sure that your services are encrypted. But they do follow a protocol called a data over cable server interface specification, and that makes sure that their transmission is encrypted in order to prevent any kind of problems like that. Alright, so here we're going to be talking about the virtual private network. It's just there to make sure that we have a secure private connection in an untrusted network. Protocols that we use are point-to-point tunneling, layer 2 tunneling, generic routing encapsulation, and internet protocol security. And the whole point is to make sure that the outside user is able to get through the internet without having to worry about losing any confidential data. And the whole point here is that the VPN server is going to communicate to the outside user using some kind of token authentication device like an RSA token. And when the VPN is going to accept that or accepts a one-time authentication code, then it allows that device to go into the inside network. That's basically in a nutshell. It's very secured, doesn't let inside attackers from the internet look to see what's going on. on their connection. Okay, we also have authentication protocols. One of them is called the password authentication protocol. It's not very secure. It sends clear text passwords. It's used as a last resort if nothing else works. But we do recommend that you use CHAP. CHAP is something that's called, it's actually called Challenge Handshake Authentication Protocol. It does address some of the vulnerabilities with PAP. It uses a challenge response system to authenticate any computer users instead of just sending a password. EAP is Extensible Authentication Protocol, and that's not really a authentication protocol per se, but it's really just a framework to enable the many types of ways we can negotiate a network connection. But anyway, these two are preferred instead of just using PAP. We also have wireless technologies. One of them is what we're going to talk about here is wireless communications, WLAN, and wireless standards. They use airwaves. It's basically using frequency and amplitude. It's very, very similar to what you use now in your Wi-Fi network at home. We use frequency hopping spread spectrum, or FHSS. We use a direct sequence spread spectrum. That's another way of doing things as far as with the wireless capabilities. And we have access points, or APs. They use open system authentication and shared key authentication. Here we have the wired equivalent privacy. That's a protocol that was first introduced by the 802.11 standard, but it had a number of flaws. It had poor authentication, poor integrity. It was very weak in creating the keys. It didn't have any randomization. So the TKIP temporal key integrity was created from the 802.11i task force as well as the Wi-Fi Alliance. It was meant to replace it as well as to make it better as far as strengthening it. And it has AES and 802.1x, and here are the different variety of security structures that are currently used today. Okay, so moving along, we have war driving for WLANs. This talks about attackers breaking into an AP or an access point to gain access to home or business networks using a wireless device like laptops, smartphones. What they do is they walk around or they try to drive by and listen for a signal. That way they can break in using their tools on their device. So best practices is to disable the broadcast SSID, to change the default SSID, or to place your AP in the central part of your building in order to limit the coverage so that that signal isn't leaked out for them to listen to. So that's really a good way to protect it. We can also talk about mobile wireless communications. First off, these all use like frequency division, multiple access, time division, multiple access. These are just different algorithms or methods to help with delivering and expanding the number of users that can access a signal, because it's very finite. So we have to have these methods in order to break it down and to provide a certain amount of coverage for these people. So here we have the growing demand for mobile traffic and XG technologies. All we're talking about here is that it's growing and it's going to get worse, but that's why we have to make sure that we have something in place. We also need to make sure that we understand we came from 1G to now we're at 4G. These are the different types of technologies that we have for mobile communication. It's getting better for the users, but that also introduces issues with security. The threats are applied, the same threats are applied like for laptops and workstations. So mobile devices are very small, they're very small computers. You can have malicious code and you can have encryption that's very weak, so we have to make sure that enterprise mobile device security is implemented to protect each user with their phones. So in summary, we learned remote connectivity. We've got to know the various types of connections used and the importance of using security protocols, because if we don't, then it will introduce any gap in our security layer and attackers can come in and take advantage of that. Wireless technologies, we have to know wireless protocols that are being used, the threats that are open to them, and the mobile technologies and the need to improve security. So basically in a nutshell, these technologies are growing and they're starting to develop and they're getting better and better in terms of features for users, but we also have to understand the complexities that are introduced when we provide security, because there are definitely different a variety of different protocols that are mixing into the system.